Okay, in this video we are going to look at the second fundamental theorem of calculus. This says if f is continuous on an open interval I containing a, then for every x in the interval, the derivative of the antiderivative of f of t dt from some number a to x is equal to f of x. So if we have this form, the second derivative basically says if we find the derivative of the antiderivative, and it has to be from some number a to some form of x to the function x of f of t dt, that's equal to f of x, which can save us some work, some time with some of these problems. So using the fundamental theorem of calculus, the second fundamental theorem of calculus, to find capital F prime of x. So capital F will represent the antiderivative, so capital F prime would be the derivative of the antiderivative. So first, we want to find the, look at this, make sure it's in the correct form. We're going from some number, which was a in the general form, 0 to x, of t plus 2 dt. Okay, so the first thing that we want to find is the antiderivative. So capital F of x is the antiderivative of this, and the antiderivative of t plus 2 dt is t squared plus 2t. Then evaluate that from 0 to x. So it gives us x squared plus 2x minus, substitute in 0, 0 squared this up a little bit. Okay, so x squared plus 2 times x minus 0 squared plus 2 times 0. And you see that this would give us 0 here, the lower limit. Evaluating it at the lower limit will give us 0. So now we have the antiderivative is equal to x squared plus 2x. So that's part one. Part two of this says to find f, capital F prime of x. Okay. So the derivative of this, remember that's where we subtract from that 1 from the exponent and then multiply the exponent times on the outside there. So subtracting 1 from the exponent of 2, that gives us x. Subtract 1 from the exponent here, that just gives us 2. That's what we had there, x plus 2. So you see, if we have this form and we want to use the second fundamental theorem of calculus, as long as it's going from some number a to x, and it's not a function of x, so it's not a cosine of x or x squared or sine of x or x to the third, then we can use the second fundamental theorem of calculus to quickly find the derivative of the antiderivative. So number 81 here, we have the antiderivative shown as capital F of x is equal to t squared minus 2t dt being integrated from negative 2 to x. So it's still in that form. So I can skip a lot of this work and go directly to the answer and say that f prime, capital F prime of x, is going to be equal to x squared, sorry about that, x squared minus 2x. And that's it. So we just simply evaluate this thing at x squared minus 2x, and we're done. Now you could go through step 1 and step 2 like we did over here, and you would come out with the same result. Okay, let's take a look at another one. We are evaluating, we have the antiderivative of t times cosine of t dt evaluated from 0 to x. So it's still in that form from 0 to x, from some number to x, from some number to x. All right, so we can quickly find the derivative of the antiderivative, or capital F prime of x, by replacing the t's with x. So x times cosine of x. Again, you could go through step 1, find the antiderivative of t cosine of t evaluated at x, and then find the derivative of that antiderivative. However, that saves you some time with this one. You don't have to do that work. Now, number 87 is a little bit different. We have the evaluation, the antiderivative of 4t plus 1 dt evaluated from x to x plus 2. So we have an x as our lower limit and an x plus 2 is our upper limit. So let's rewrite this. Let's break this interval up into 2 separate intervals and see if we can rewrite this and use that second fundamental theorem of calculus. So I'm going to rewrite this and go from x to 0 of 4t plus 1 dt plus, and we'll go from 0 to x plus 2 of 4t plus 1 dt. Now remember, in our general form, the integral was from some number to x. So looking at this first part here, where we have from x to 0, we want to get this lower bound and upper bound flipped. And remember, when we do that, we just put a negative out in front, do the negative of it. So 4t plus 1 dt plus 0 to x plus 2, which is okay, 4t plus 1 dt. Now we can find the derivative of the antiderivative by simply evaluating this thing at x. So minus 4x plus 1 plus 4, replace t with x plus 2, x plus 2 plus 1. So negative 4x minus 4. Okay, not 4, I'm sorry, minus 1. Distribute the 4 here, so plus 4x plus 8, and then plus 1. Now, once I simplify these, the negative 4x will cancel with the positive 4x. The negative 1 will cancel with the positive 1. I'm just left with 8. So in other words, the derivative of the antiderivative of 4t plus 1 dt from x to x plus 2 is equal to 8. All righty. Thank you.